Example 5.8 or 6.8 from the given textbooks. For details, please see the description below. R134A enters a capillary tube of a refrigerator as a saturated liquid at 0.8 megapascals and is throttled to a pressure of 0.12 megapascals. Determine the quality of the refrigerant at the final state and the temperature drop during this process. In the case of a throttle valve, the information that we know is that the value of enthalpy remains constant through the process. Therefore, the value of H1 is equal to the value of H2. We're going to use the information that we have in the inlet to be able to find the value of that entropy. In the inlet, we know that the pressure is equal to 800 kilopascals, and we also know that it's going to be a saturated liquid. Therefore, we're going to go to table A12 to be able to get the information. In table A12, we go to the pressure of 800 kilopascals, and we go to the value of HF, which is the saturated liquid value, and we get 95.48 kilojoules per kilogram. We also find that at that particular pressure, the temperature is equal to 31.31 Celsius. Now that we know the information for the inlet, let's figure out the information for the outlet. For the outlet, we have that the pressure is now equal to 120 kilopascals, and we know that the value of H2 is equal to the value of H1, which is equal to 95.47 kilojoules kilograms. We are going to go back to table A12, and we go to that pressure of 120 kilopascals, and we see the value for the enthalpy. It's about 95, and is between the saturated liquid and the saturated vapor, which confirms that this is a saturated mixture. Notice that one of the questions was to find the quality, which only takes place on a saturated mixture. For those two values, we also find that the temperature at that point is going to be negative 22.32 Celsius. Now that we have the values of the enthalpy, we're going to be able to find the value of the quality. Quality is defined as H at that point to HF divided by HFG. If we substitute all these values, we find that the quality is equal to 0.34. The next part in the problem is to find the change in the temperature. Notice that delta T is simply T2 minus T1, and we have it to be negative 22.32 Celsius minus 31.31 Celsius. Therefore, the drop in the temperature is going to be negative 53.63 Celsius. And we want a large drop in temperature because that is the purpose of a throttle valve.